Hello and welcome to the final episode of this season for Stellar Journeys. Thanks for joining us. My name's Ash, this is Emily, and once again we've got back our good friends Jonty and Jonah, and we've got a few extra guests joining us today in Masood, our lovely creator, and Stuart's back from episode 4. Good to have you here again, everyone. So far on the series, we've been exploring exoplanets. We've started out looking at what they are and a few of the ways we can find them. And we've also looked at some of the problems and the technology that we're currently using to help broaden our search for what's in our universe. Today, we're going to look into some of the questions that we've all had. So I thought I'd kick us off today. Basically, I want to know, what are some misconceptions in the field? What do you guys get asked that or what gets told to the public that's not really accurate? We'll start with you.
There's a lot in there that ties into the use of language, and a lot of the misconceptions come when the same language means different things to different people. And a really good example is astronomers will talk about looking for an Earth-like planet. And what that means to most people is, oh look, a blue marble with continents and bipedal apes walking around and having deep conversations about things they don't understand. When an astronomer says an Earth-like planet to another astronomer, they're meaning something about the size of the Earth and maybe about the same distance from a star. And so that kind of confusion leads to misconceptions that nobody realizes is happening, because you've got this linguistic blinkers on that whenever you see it written down, it means what you understand it to mean. So what that leads to is people think we found lots of planets like the Earth out there, whereas I'd argue we haven't found any planets like the Earth out there. We found planets about the right size, but that's about all we know. And if you looked at our solar system from one of the nearby stars, you look at it and say, well, there's at least 2 Earth-like planets there, possibly 3. You've got the Earth and Venus and Mars. If you look at Venus and call it an Earth-like planet, people are like, are you crazy? It's hell. Yeah. It's 450 degrees there, you'd melt lead. You wouldn't live long enough to complain if you're on the surface, because you'd be broiled and dissolved. And yeah, but in the context of exoplanets, if we found Venus around the sun, we'd probably think it was probably one of the most Earth-like planets we'd ever found. That would translate to being reported as being an Earth-like planet, Earth 2.0, habitable world, and it's not. And so it's just a real communication problem, and scientists are as much to blame for it as anybody else, but it boils down to the fact that we've got a language where words are able to change their meaning. And you'll get a lot of people saying, oh, well, it's just a theory. But to a scientist, the word theory means a very specific thing, very different. And Earth-like falls into that category.
That's incredible. So when scientists on the news, whatever, say Earth, like they're not talking a lovely blue planet where with gorgeous waterfalls, it's just the right size.
But the bonkers thing with that is that if you took the general public view of Earth-like, for most of the Earth's history, the Earth has not been an Earth-like planet. We've not had an oxygen-rich atmosphere. Yep. You know, I've seen suggestions from people who are far wiser than I am and understand oceans better that the oceans weren't blue back in the day because you had a different composition of the atmosphere. They weren't oxygen rich. Things follow on. So the Earth 3 billion years ago would not have looked Earth-like from the point of view of a sci-fi series, but we'd have still called it an Earth-like planet because it's about the right size, about the right distance.
What does habitable mean to you?
Habitable is another really good example. Habitable does not mean inhabited. All it means is that if we talk about a planet potentially being habitable, what that means is that it may have the right conditions for life on it. And even then you've got a linguistic bias there, because when we talk about life, if you've watched Star Trek, like The Wonderful Pizza Cutter, you think about intelligent gas clouds and molten metal people wandering around on super hot planets. But in reality, when we're talking about habitable, we only know of one kind of life, which is life on Earth. And so we're really looking for places like the Earth, like the conditions in this room, because we can imagine intelligent hydrogen clouds, but it's a lot easier to look for something you know exists than to look for something that you can think might exist but you don't know. So quite often what habitable means is simply that there are the conditions there that life from Earth could survive in. And that's where the habitable zone comes from. The idea of the habitable zone is always pitched as a planet you could go live on. A planet where it's not too warm, not too cold, but just right for liquid water on the surface. But what it actually is if you took the Earth with its current atmosphere and put it in that region, would it still look like the Earth? So Venus is not currently viewed as being in the habitable zone, but if you put the Earth where Venus is at the minute, the Earth would not look like Venus because they've got a different atmosphere. And so it's a lot more complicated, but it's very easy to paint with broad brushstrokes when you've got only a 15-minute episode instead of a 15-episode series.
Thank you. That's incredible, Jonty. Jonah.
Yeah, I was gonna just to follow up on that. Yeah, like finding like a habitable planet kind of being like life on Earth, because it's really the only thing we can look for. Let's say that there was some sort of maybe silicon-based life, like, I don't know, robots or something living on other planets. We just have no idea what we're even looking for. Because the main diagnostic tool that astronomers have to kind of distinguish whether a planet is habitable or not is both its size, its distance from the star, and for a select few, and hopefully in the future a lot more, its spectrum or its atmosphere. But if there was a planet that was inhabited by robots or some sort of silicon-based life form, what would we be looking for? What signals are we searching for? This kind of then goes into the realm of philosophy, like kind of what does it mean when we're looking for life? So yeah.
And I would argue that something that Jonty mentioned earlier on is that habitable, if we're talking about life, may not be what we think. So, for example, you mentioned Europa, which has an ice layer, but potentially free-flowing oceans underneath its surface, where possibly there may be life.
And I think that's a really important point to make, is that we're finding places in the solar system that are potentially habitable. So they have the conditions which on Earth would lead to life. So on Earth, as an astronomer, life needs energy, nutrients, and water. And you can go well beyond what we call the habitable zone, where you'd have liquid water on the surface of Earth, to places like Europa, which is 5 times further from the sun than the Earth. The top of the ice is 150 degrees below freezing. Yep. But beneath the ice, you've got an ocean with volcanoes spewing nutrients. It's habitable, potentially, but it's not detectably habitable because we've got a 10-kilometre thick ice sheet between us and the water. So that's the other thing that explains this bias towards Earth-like planets when we're searching for stuff, is there'll be far more habitats like Europa in the universe than there are habitats like the Earth. But they're the ones that we cannot, with current technology, search. We don't even know if there's life on Europa and it's in our backyard. If it was around another star, we'd be lost. So we're limited to look at planets with atmospheres where the life could be on the surface. And so we've got a difference there between habitable and detectably habitable.
So we've got, I had this misconception until you explained it to me, that what habitable meant. I expected it to be exactly like Earth. Sticking to that idea of a planet that is like Earth, do you think we will find that? Or do you think we'll find a traditionally habitable planet for us to live on?
We're playing a numbers game, and the optimists and the pessimists disagree to some degree, but at the end of the day, you've got so much real estate. So if you have 400,000 million stars in the galaxy, and that's an estimate, right to within a factor of 2. If all those stars have planets, you've got a trillion planets in our galaxy. There are more galaxies in the universe than there are grains of sand in our galaxy. So the numbers get to sextillions. Bonkers numbers. The likelihood that this is the only place like this out of all those worlds is vanishingly small. So it then becomes a question of the optimists and the pessimists disagreeing on proximity. Is it next door, or is it in the next galaxy over and we'll never get to it? And so for me, I think that's where it comes to. And I mean, if you went back to when the solar system was young, back when the Earth was an Earth-like planet that wasn't at all Earth-like, we probably had 3 Earth-like planets with oceans, with atmospheres that were temperate in the form of Venus, Earth and Mars. And those triplets have gone very different career paths, and you've got the one that has become hell incarnate, you've got the frigid ice ball, and you've got the one that's sat in the minute, which has just miraculously stayed just right, thanks to this chaotic interplay of life and the atmosphere. And as the sun's got brighter, life has just kept the Earth habitable by fluke. The other two have gone other ways. They left the band before they were famous, and we're left with the Earth being the place to be.
And we happen to find ourselves on the only place we could be.
Absolutely.
So I guess the future is looking towards finding more exoplanets. Jonah, I wanted to draw on your sort of expertise here. Where's exoplanet missions going? What are we looking for? What options are there?
A great question. I mean, at the moment, we've got a couple fantastic missions that are currently undergoing, such as JWST, which we mentioned before, which was launched last year. But we've also got a bunch in the I suppose, in the shelf ready to come out, coming in the next couple decades or so. You've got missions such as Ariel, which is going to do something called transmission spectroscopy really well. This is where you've got that transiting technique or winking technique where a planet crosses the star. But what happens is as it crosses the star, some of the starlight will go through, if the planet has an atmosphere, it will start to go through that atmosphere. If you've got a really good instrument, you can actually kind of disentangle the light coming from that planet, coming through that planet, from when it's just the star by itself. And you can kind of actually start probing the atmosphere of a planet as it transits across the star. So that's one really cool kind of mission, and we're doing that with a couple ground-based telescopes already. But another really exciting mission that I'm working quite a bit on is it's a mission called LIFE, actually. It's kind of
Aren't we all?
Astronomers love an acronym.
yeah. But this one is actually, unlike most acronyms, such as the VLT, Very Large Telescope, is actually a good acronym, which stands for Large Interferometer for Exoplanets, which will be maybe in the 2040s, 2050s, a set of 4 to 5 large telescopes, all flying together, as we were talking a bit in episode 5, with the hope of actually being able to take some pictures of planets going around other stars and getting the light from Earth-like planets around solar-type stars.
This comes back to an information thing. So the amount of light that you're going to get, obviously, as the light moves, every time it doubles the distance, it kind of quarters or 1/8, whatever it is, the inverse square law, the amount of light that you're going to get. These stars are very distant. How much of an image can you get?
Well, so one of the interesting things with an interferometer is I've been saying taking an image, but it's less taking an image and more seeing the light directly from the planet. You're not going to get a nice, beautiful image like you might see artists' impressions of. And you're right, planets and stars are very far away. In fact, this mission will probably be restricted to roughly the inner 80 or so light years around Earth, which in the grand scheme of things, absolutely tiny, probing barely any of the galaxy. But it's still, there's still enough probability that we'll be able to catch maybe 1 to 5 planets similar in size to Earth in similar locations that we'll start to be able to probe whether or not there might be like a beautiful ocean-filled continents, rolling green hills type planet around nearby stars. But we'll have to wait and see for quite a bit of time still.
That's sort of all the time we have on this series. I'd like to extend a big thank you to our wonderful audience who watch and support us. It's been an absolute pleasure presenting to you. We've had a wonderful team around me. Again, thank you, Jonty. Thank you so much, Emily. Thank you, Jonah. Appreciate your time. Stuart, for always being a good person to have on set with us. To the wonderful crew behind the cameras as well. You don't get to see what we see, but the amount of work that has gone into this is just beyond imaginable. It's out of this world, for lack of a better term. Thank you all, and we will be back for season 2.